Greetings, ladies and gentlemen. Hope you are doing well. This is TJ's Maths and Further Maths Adventures. If you're new here, please consider subscribe, hit the notification button so that you'll be notified whenever I upload a new content. Thank you for joining me. This is Mathematics. This is JAMB 1978. We have question 46 and question 47. Question 46 reads, the vectors A and B are given in terms of two perpendicular unit vectors I and J on a plane by vector A, which is given as 2I minus 3J. Vector B is given as minus I plus 2J. The question said, find the magnitude of the vector A plus 3B. We have the options here. So, let's write down the solution to 46. Okay, I and J, I is associated with the x-axis, J is associated with the y-axis as far as vectors is concerned. This is vector in 2 dimensions. We have vectors in 3 dimensions. Okay, so we're asked to find the magnitude of A plus 3B. Let's write down vector A, which is 2I minus 3J. Vector B from the question is minus I plus 2J. So for us to find the magnitude of this vector, we have to substitute vector A and B into this. So this will be 2I minus 3J plus 3 into minus I plus 2J. So let's remove the bracket and add I to I, J to J. So this will be 2I minus 3J minus 3I plus 6J. 2I minus 3I, of course, it will be minus I, minus 3J plus 6J, it will be plus 3J. So the next thing now is to find the magnitude of these vectors. So let's remove the question and leave only the options. Okay, so that we can solve the remaining aspect of the question. So we have minus I now plus 3J. Let's define this as vector B. The magnitude of this vector B now, which is given as this, will be equals to the square root of x squared plus y squared. Okay? So this will now be, in place of this x, the coefficient of I here is minus 1 all squared plus the coefficient of j, which is associated with y now, is 3. That will be 3 squared. We take the square roots. And this will be minus 1 squared is 1 plus 3 squared is 9. So that will be 1 plus 9 is root 10. That will be root 10 units. The correct option here, let's check, is option E. So the correct option is option E, which is root 10. Okay, let's move to question 47. Let's move to question 47. Let's clean this so that we can have enough space. Okay, the question reads, in the figure below, we have a figure here, angle ABC, and angle AED are all triangle. In adjacent plane, they are in adjacent plane to each other. These two triangles, they are adjacent to each other, such that length AB is the same as length AC, which is given as 5 cm. Length BC, length B to C is given as 6 cm. And angle ADE, that is this angle here, is given as 60 degrees. Then what will be length AE? We don't know. Length AE will be equals to what? Okay, let's analyze this question critically. I were told from the question that AC is 5 cm, meaning here is 5 cm. Another thing again, BC is 6 cm, but AD is the perpendicular bisector of length BC, meaning AD divides length BC into 2 equal parts. So if BC is 6, here will be 3 cm, and here will be 3 cm as well. So we can easily find length AD because we can cut out this. It will be like this. To be a right angle triangle. This is our angle 90 degree. Here is 5. Here is 3 cm. We can find AD. AD now will be let it be Y using Pythagoras rule. Okay, this we apply Pythagoras rule when two sides of a right angle triangle is given and we are asked to find the third side. We apply Pythagoras rule. So this will be 5 square equals to 3 square plus y square. This is 25 equals to 9 plus y square. 25 minus 9 now will be equals to y square. So 25 minus 9 of course is 16. That will be y square. We can take the square root of both sides. Y now is 4. So this length AD is 4 cm. Okay, since length AD is 4 cm, now we can use that to find length AE. Okay, because this is 90 degree. This is now the hypotenuse, and of course, this will be the opposite here. Okay, so we are looking for the opposite of this because this is a right angle triangle. Okay, so we apply what we call SOHCAHTOA. Is it sine or cosine or tangent we are going to use? Opposite, this is opposite, and this is our hypotenuse. Opposite hypotenuse is sine. Opposite hypotenuse. So we have sine 60 degree now. Opposite here is what we are looking for, which is length AE divided by the hypotenuse, which is 4. So which is 4. So we can cross multiply here. Length AE now rather will be 4 times sine 60 degrees. What will be sine 60 degree? We can get that from special angles of 30 and 60. Let's remove the question since we are almost there. So let's use our special angle here quickly. The special angle is given like this. Let's say we have an equilateral triangle of 2 units like this. Here will be 1, 1. Of course, here will be root 3. This is 60 degree. This is 60 degree. And this is 30 degree because all the angles in an equilateral triangles are equal. All the lengths are equal. All the angles are equal. So sine 60. Sine 60 now will be, we'll consider this 60. This will be the opposite, then hypotenuse. Opposite hypotenuse. That will be root 3 divided by 2. So length AE now will be 4 times root 3 divided by 2. And this will be 4 root 3 divided by 2. Okay? 2 here, 1. 2 into 4 is 2. The final answer now will be 2 roots 3. From the options, let's check the option. Option A is 3 roots 2. No. Option B, 2 roots 3. Yes. So the correct option is option B. Thank you for watching. Please do share this to your learned colleagues.